Hey, what's up everybody? This is Andrew Whitaker. In this video, I'm going to be showing you the whole process of fuzzing an application to writing a stack-based buffer overflow exploit. Then from there, we will port it over to Metasploit, and we'll have some fun with it then. So this is going to be a multi-part video because YouTube only allows you to do like 10 minutes at a time. And also because I really don't feel like spending an entire day editing this film, I'm just going to do it all in one take. So forgive any typos because I'm doing it in one take. So let's get started. All right, so first off, let's talk about this application. I'm using Steve Bradshaw's vulnserver.exe. This is a great application to learn about exploit development because he wrote a telnet server that's intentionally vulnerable. And I'll go ahead and launch it here. It listens on port 9999 by default. So my IP address is 10.0.1.21. If I go over here to my backtrack box and I'll telnet to that box on port 9999, and it says welcome to vulnerable server, enter help for help. I'll type help, and it shows you what the valid commands are. Now, from exploit development perspective, all of these are potential buffers that you might be able to exploit. I'm going to use the spike fuzzer to try to exploit these and see if I can get the application to crash. It's pretty simple though. We do commands like the stats command followed by some value. I'll just say command here. And it comes back and just gives me some return output. Let's go ahead and exit. All right, I'm going to use the spike fuzzer to send data to each of these for each of these commands. So we'll go into the pen test fuzzers spike source directory, and I'll do an ls to show you what's in here. We see that there's several built-in programs that will make connections. I'm going to use the generic send TCP. Now, one thing I noticed about or about the spike on backtrack 5 is that when you type in the command, it tells you that there's an error loading shared libraries. And I did a little Googling and found a good fix for this. If you just type in period space ld.sh, it will fix the problem with these not having these shared libraries. So now if I do the generic send TCP, and we see there that the syntax for it is you pass generic send TCP, the IP address, so the IP address of my Windows box, and then the port number, and then your script. And what your script is going to do is send what commands you want to do. In our case, it'll be the stats command, the rtime command, all those commands that we saw when I entered help. And the skip var and the skip string there, that's if you want to, when you start it off, if you want to skip some values, maybe you've already tested them before. I'm just going to keep it at 0 and 0 to start from the beginning. So I'm going to create a script here, spike script, put it in my root directory. Let me open up a new terminal here. Open tab. And again, if I telnet to that box, let's just do this for review. Type help. Here's a list of all of the commands that are vulnerable, or that could potentially be vulnerable. So let's create one here for stats. So I'll type stats. We'll create a file called spk and open it up with the nano text editor. Now, Spike has some predefined functions. Start with s underscore. These are all the string functions. I'll do read line. Read line is going to read what the server sends me. In this case, the server, we go back here, the server sends me a banner. It says, welcome to vulnerable server, enter help for help. All right, so that's what this is doing. It's just receiving that first line of input. And then I'll put in the string stats space, and that is going to be for the stats command, followed by some value here. So that'll be the string variable. And what the string variable is, that's the actual fuzzed information. It's going to start with whatever I put in here, and then it's going to just randomize it and to try to do some fault injection. So I'll save it, and let's launch generic. The send TCP, put in the IP address 9999 for the port, followed by the path to my spike script, and then 00, again that just says start from the very beginning. We'll go ahead and run it here. And right now it's trying to fuzz. It's trying to pass just random data to the application to see if we can get it to crash. And notice, at the very end it says line red, welcome, which means this was not able to get the application to crash. You'll notice here the application is still, minimize this, application is still running there. It has not crashed. All right, well, we still have some other options. So stats did not work, but we got several others. Now, just for the sake of time, I'm going to jump forward to one that I know is vulnerable, which is the trun command. So I'll create a script, nano, and we'll call it trun.spk. We'll do the read line. We'll do the string of trun space, and we'll do our string variable, and we'll save it. And now we'll do the generic send TCP, the IP address, the port, the file, the script file I just created, and 00 to start from the beginning. And we'll pass it. And notice when I go back here, sure enough, it did crash. That's awesome. So now we need to figure out what caused it to crash. And more specifically, how many bytes caused it to crash, because we want to try to find that saved EIP value. So I'm going to go ahead and launch it again. And this time I'm going to launch Wireshark in the background. And then I'm going to capture the traffic that I'll send to it on ETH1. And let's just get that out of the way. And we'll send it again. And sure enough, we got it to crash again. That's good. Let me close out. And now let's take a look at Wireshark. Now, Wireshark's going to capture a lot of stuff, so just to kind of filter it out here, we'll stop it. I'm going to do tcp.port == 9999 as a display filter to just filter out the traffic that's sent to port 9999. Now, let's right-click on the first TCP packet here, or segment, and go to follow TCP stream. All right, first one we got here is welcome to vulnerable server, enter help for help. That's what it sent to us. And we pass trun command, and it comes back trun complete. The fact that it is able to return trun complete tells us that this was not the TCP stream that caused it to crash. So I'll filter that one out by clicking filter out this stream. And let's go on to the next one. Right-click, follow TCP stream. All right, we got our banner message. Here we pass the trun. This time we're passing a /.:/ and then a whole bunch of A's. And notice at the end we do not see that trun complete command sent by the server. That tells me that this is the message that caused the application to crash. So let's save this. I'm going to save just what I sent to the server. And we'll click save. I'll save it to the root as crash.txt. And we'll quit out of this. And what I want to do is see how many bytes it took to get that application to crash. So I'm going to do the wc-m command to count the number of bytes for, I think I saved it on my desktop here, wc-m crash.txt. It tells us it took about 5,009 bytes. Okay, so roughly about 5,000 bytes.